All right, so for the house drawing thing, and also for anyone who's watching the video that I'm recording now, which is obviously no one in here, but for the people who are absent. For anyone who's watching this video, we've created a new project. The name of the project is House Drawing, and it has no spaces, a capital H and a capital D. We have imported into our project the ACM jar, and I'm going to go ahead and show that on video just so you can see if you are absent. You click on the project structure folder here in the top right. You make sure you're on modules, then dependencies, and then you hit this little plus button, and then you add a jar or directory. Yours will be wherever you saved it to. If you don't have it, please go onto Canvas and download them from the files section of the course. Once you have found acm.jar, make sure it's not acm.zip. If you download it from Canvas, it'll be acm.zip. You have to extract it first. So once you have just the jar file, add the jar, click the jar file, hit OK, then hit apply down here, and then OK again, and you'll be ready to start. All right, now back to the normal thing. Up here on the whiteboard, let me show you what our goal is. Sorry for anybody who is watching this video. Our goal is to draw a house that looks something like this.
That's pretty cool.
We will do this with, obviously, code, and that's it. But just a simple little house. One time I animated smoke coming out of it, but that took like way too much time to be worth it, so we're not going to do that probably. You also don't know how to do it. I mean, Cam does in the deep recesses of his mind. But anyway, this is our goal, essentially. We'll also color it nice and everything. But this is what we're going for. So, and there's other customizations you can do down the line. This is the goal. And to do that, we need to have a screen to draw it on. So step one, let's get a screen to draw it on. To do that, we are going to go, and if you're watching the video, now's the time to be back. You expand over in your project tab, you're going to expand the house drawing folder. Go down to SRC, that's our source code folder. That's where we do pretty much everything. Right click on SRC and do a new Java class. The name of this class is House Drawing, exactly as we named the project. So therefore, no spaces. It's important, the no spaces, and capital H, capital D. Where's the what? SRC is over in the project tab under House Drawing folder, and then you have a little blue folder called SRC. That is not right. That is not right. Does everyone know where their SRC folder is? Otherwise, we can do new Java class. Okay. House drawing. Anybody else? All right, once you've done that, you should have a window like so, which is a class, but it's empty. So we've all made it this far. Hit enter on that. Let me take a look. File already exists. I don't know. Just to make sure.
Right click. Class. That's the house. Drawing. That was just I know.
Okay. So now we need our entry point. What's the entry point? Main. The entry point is main. And if we write main, it will infer that what we want is the main method. So if you just type the word main and then press enter, it will create the main method for you, thus removing the chance that you'll cause a mistake. This is good start. Thank you for doing that for Aiden. Okay. Next, we need to import the graphics program class like we did last time so that we can get that window to come up. So go up above your class and import acm.program.graphicsprogram. By all means, please use the autofill thing to help you not make any mistakes and to do this quickly. You can navigate through the autofill box using the arrow keys and enter to make a selection. You can also scroll through it with your mouse and you can double click to select. Obviously the arrow keys and enter are faster. Good? Now that we have this imported, we need to extend it. So we need to make house drawing into a graphics program. We do that by going right after house drawing here and putting extends graphics program, and it already tries to autofill it. So we're going to use that tasty autofill to get everything finished quickly and with no errors. Everything good so far? Anyone got any errors at all? Cool. Okay. Now that we've extended this, all we need to do to get a window up is to declare a new instance of the house drawing class, we need to instantiate house drawing and then tell it to start. Tell the instance to start. How do I instantiate house drawing? Do we remember from last time? We declare it, yes. So let's declare a new house drawing. How do I do that?
House drawing.
Yep, house drawing, just like that. Whoops, not like that. Like that.
Yeah.
Then we have to name it. We'll just call it EX. Equals, yes. So just before we continue here, this right here is a declaration. We have declared a new house drawing, right? Everybody understand that? All right. Now we're setting this equal to a new instance of the house drawing class, which is called instantiation when we do that. This whole little thing is called instantiation. So equals new house drawing, semicolon. So this right here is referred to as instantiation because new house drawing creates an instance of the house drawing class, names that instance EX, and then we're set to go. Anyone confused about how instantiation or what instantiation does? Good. I hope that's actually true. So now all we have to do is tell EX to start. The start method is a member of the EX class, therefore how do I call it? EX.start, yep. The member access operator, the period. Now if we run our programs, which by the way, whenever we do a new project, the first time you run the program, you need to do so by clicking on this green play button next to the main method. I'm pretty sure the one up by the class works as well, but just do the main method one. And then, so click that and then push run, and your code will execute, and you'll get a window. Hooray, hurrah. Come back. That's not right. There we go. Yeah, that is technically true. It's a good thing everybody in here has a 10 out of 10.
Or 0.
Well, if you're absent. It's almost impossible to fail. Okay. Anyway, if you ran your program, you should be currently looking at a blank window. I would like to see this blank window on everyone's screen, and if you have any issues, and leave it up on your screen so I can tell. If you have any issues, let me go around and fix them. All right, generally I'm seeing the windows. If you don't have a window on your screen, please get it up on your screen so that I can make sure that you know what's going on. Michael, what's your error? Great. Please leave the window up on your screen so I'll be able to look around in a second. Make sure. Cuts off all the power. You just keep them right there.
I remember those. I used to put those on my cell phone. Is anyone else home? I'm so.
I just about bought whatever happened last time. Better uses for my money than more.
All right. Looking around. All right, let's move on. So we've got our window. We're also going to need an init method. That is written as public void init, just like so, and you put @override on top of it. That does not mean that you need to write the main method again. I hate it when people do that. I've told you, there's only one main method per program. It usually signals to me that you weren't paying attention and then got startled and just copied everything you could see. What? Did you say I'm not wrong?
I said he's catching on.
He's catching on, yeah. There's always the same basic set of mistakes that people make. You know what would make this class easier is if the only desks were these middle chunks, because then only you now have to like all the time. That would be better. I need like wall-to-wall rows of desks and one middle aisle or something. If we got faster computers, I could just like do a stream from my computer and you could just have like open on the side. That would be way easier.
Way easier.
But based on our current technology, we don't have to.
Maybe next year. Return for programming 2. Electric
I'll
Boogaloo.
get right on that. I'll fail senior year.
Easy. Easy. Okay. Everyone got the init method? No errors, at least visibly? Everybody good? Speak now or die? Okay. If I have to correct any errors now that I've asked for it directly, I will fail you. Okay. Now the init method doesn't do anything yet because we haven't given it any code. Now, let's take a look at this. Here's what we're doing. Let's say that this is our window. And up, there's the taskbar at the top that says house drawing on it. And there's the part here that says like file and edit or whatever. Okay, here's our window. Now in programming, a lot of the time when you're if you're professionally programming, you're presented with a problem. As a programmer, all it really is up to you is to get a list of everything that the program needs. So if you're making an app for someone, you'd be like, okay, do you need a login screen? Do you have an icon that has to be used for your login screen? Do they use emails, Google, whatever? You just ask for all of these conditions, and then you just take all that information and you use it to solve the problem using the toolbox of code. That's basically it. We're going to do that in a really simplified way over and over and over again this year. So our first major project, aside from the thing that I gave you last time, is to draw a house in the window, centered in the window. But we'll get to the centered thing in a minute. Let's take a look at our house. That's a little wider than I intended, but it'll do. It's a thick house. You can name your house later if you want. You can put a G label on it. Be like, this is the...
That house is thick with 2 C's. Okay.
You can do that if you want. Although I don't think there's a way to tilt a G label, so you might have trouble with that part. But anyway,
The thick boy household.
ignoring the thick boy household, yeah, draw a mailbox and put the. Yeah. Okay. So here's our house. Now, if we broke this down into individual little shapes, we can see okay, both of the windows and the walls and the chimney and the door are all rectangles, and there's a class for that. It's called grect. ACM has it. So we did G labels before. Now we have grect, or basically a G rectangle. Okay. We do have 2 other shapes though. We have here a G oval.
A jovel.
Sure. Well, it's a goble actually. And then the roof is a triangle, and we make that with something called a G polygon.
Yo, we're my G parallelogram.
So given these little pieces, we need some more imports. So jump up here underneath our first import. We need 3 more. We need to get access to the grect, the G oval, and the G polygon. To do that, we just do import acm.graphics.gpolygon, or we'll do in order. grect, import acm.graphics.goval, and acm.graphics.gpolygon. 3 imports. They'll be gray because you're not using them yet. So just break Understand that as we do this, we're just breaking down this slightly more complicated problem into its constituent parts. We want to draw a house? Okay, step one. How do we do that? With a bunch of simple shapes, okay? What are those simple shapes? We need a triangle, a sphere, and a rectangle. Okay, cool. Let's import stuff that lets us do that. That's our logic here. I want to erase as little as possible so I can keep my... Let's start with the walls, because everything else is attached to the walls, so we kind of need it. We simplify our drawing then to just the walls. We want our walls to be right here, in the middle of our screen. Makes sense? Now I know I didn't draw it centered, but the idea is to have the walls be centered. The walls are a what? Or what will they be?
G-rect.
A G-rect. Okay, so declare for me as a global variable, aka up here in the top of the class. Again, back on your screens. Declare for me, here at the top, a global variable of type G-rect and name it walls. Make the access modifier private. Declare a private G-rect and name it walls. We're going to try to get an instance of G-rect. Is this?
You don't want us to assign?
Do not assign. I'll show you why later. Crap. All right, hopefully that only took you a couple of seconds. Here's what this should look like. Private, G-rect, walls. If you capitalize walls, please make it lowercase. We're not going to worry about studying it yet, but there's something called naming conventions, and there's a certain way that we type certain things. I don't want to over confuse you, so we're not covering it now, but lowercase. All right. Now, here's the thing. We've got all those parts. You got the walls, the chimney, the door, the windows, the doorknob, all that. And we could easily go in here in init and write all the code that we're going to need. However, if we do that, our code will A, look a little bit messy, and B, if something goes wrong, it'll be difficult to debug because our code won't be isolated down into very specific chunks. So instead, we're going to make one method for each part. So we're going to have a method that handles drawing the walls. We're going to have a method that handles drawing the windows, the door, all separated. And then in the init method, we'll just call them in order. That way, if something goes wrong, we can say, it went wrong with the walls. So we look in the walls method. We don't have to check anywhere else. Now, I could just go and actually, I'm not going to have you do the thing that will let you create this automatically. Write for me down here below init. Again, right here below init. A empty method that doesn't return anything and has no parameters. The name of the method will be draw walls with the W capitalized and no spaces.
The D not capitalized?
Huh?
The D isn't capitalized?
The D is not capitalized. Draw walls, lowercase d, uppercase W. It does not return anything. But it is a method. It doesn't return anything, no parameters.
Is there a space between draw walls?
No space between draw and walls. It won't even let you do it, actually. It's a syntax error if you put a space. Anyone still? I hear some keyboards moving. Someone tell me the first thing I would write for this. Let's do private, actually. It's okay if you wrote public. That's fine. We're going to go with private, though. If you want to change it, that's okay. It's better practice. Like, if it doesn't need to be public, you should just always make it private. That's the general rule. All right, what's next? Void, because it's not returning anything. And then the name of draw walls. I said there's no parameters, so what comes next? Parentheses with nothing in them. And then an opening bracket and the closing bracket. How many of you got it? Public, if you put public, is also fine. How many of you got it? Raise your hand if you got it, I should say. Okay, for those that didn't get it, what part did you miss? Okay, that's fine. Remember now, from now on, remember, variables can have the equal sign, methods do not. And just keep that in your head. All right, anything else that people, like if you didn't get it, what did you put instead? What aspect did you miss? Or was that the only one? I want to correct small errors now.
At the end, I just forgot the curly braces.
Okay. Methods need the curly braces to carve out their own space out of the class. Anything else? No? Not everybody, a lot more people didn't raise their hand than said they had something go wrong. So either you had the same things go wrong, which is fine, but I just want to make sure that if something different went wrong, you let me know so I can address it. We all good? Okay. To make the draw walls method run, we have to call it at some point. See how it's grayed out right now? The graying out is telling us, hey, you never use this. To use it, we'll go up in the init method because init is automatically called as part of a chain. When we call start down here, the graphics program has that start method. When you call start, it does some stuff that gets the window going, and then it calls init by itself. So init is already running, so when init happens, we're going to tell it to draw the walls. And now you'll see that draw walls lights up because we're actually using the method. So everyone call the draw walls method from inside of init. Okay. Now the draw walls method currently does nothing. But what do we want it to do? We want it to draw some walls that are centered in the window. Well, let's take a look at this. First off, walls is not currently assigned any value, as you can see. We declared it, but we did not put a value in it. So let's put a new instance of the GRectangle class into walls. So please, down here inside of draw walls, assign a new instance of grect to walls. You'll probably get a little red underline on your parentheses when you do it. Please attempt this though. We'll get to the little red underline in a second. But again, you are assigning a new instance of grect to walls. Oh dear. That sounded like a heavy water bottle.
I don't know, it's all over the keyboard.
All right. I still hear a little bit of typing, but I think generally speaking, we've got it. So what do I write here? Someone give me the very first word.
G-rect.
Not quite.
I'm gonna try.
No, it's okay. What did you put after G-rect?
Wall.
Okay, so that's close. We're missing one thing before the equal sign, though.
Wall.
Walls. So here's why. And the reason it's not G-rect is because we already declared a G-rect up here.
Wall equals G-rect.
Yes. So it's walls equals new G-rect. This is just separating the declaration and the assignment. We declared walls up here as a global variable. We are assigning to it down here much later in our program so that walls only gets assigned to after the program actually starts. This is more of a best practices kind of thing than something that's important right now. Now, how many of you got the right half, like the equals new G-rect part? How many of you got that? Okay. So that's not a lot. Like that's about a third of you. So when I use the word instantiate, that means I'm assigning a new instance, right? Instantiate instance of a class to a name. Now that new instance thing should stick in your head because that's where you get the new keyword from. We're saying that we want to make a new G-rectangle. We want to create that. And then we want to take it and shove it into the walls space. So we created a space. We isolated it out for walls. I'm trying to think of well, I can use my cooler as an example of that.
Look at it.
Right. So I got my little lunchbox cooler thingy.
Yeah.
This is I declare a new G-rect named wall. So I made this space for it. But there's nothing in it. It's empty. Then, when I instantiate G-rect, and this is kind of a silly object lesson, I wish I had a cardboard box or something, but I've got my ice pack, right? This is the instantiation part. I just created this from nothing. This is a G-rect. Then I put it inside of walls, and then anytime in the future that I need to get any information or anything about that G-rectangle, I go to walls, open it up, and pull out what I need. That's how instantiation works.
So you can put in multiple stuff as walls.
No, don't get confused. Pretend there's only enough space in here for the one ice pack.
Oh.
Yeah, we can't. Now, that's kind of true, but here's the thing. So if I've got a primitive variable, that's simple. That's a number, right? Or a little piece of text. That's really simple. If I've got a whole G-rectangle, a G-rectangle has an outline color, a fill color, a width, a height, an X position, a Y position. It has a lot of information in it.
That's too cool for the chair.
Now pay attention to this because this actually matters. Because this came up last class and I want you to understand this. When we make a fully fledged object like a G-rectangle or a G-oval or a house drawing, all of those G-recs and everything, those are instances of classes, right? So we've been writing simple classes, but a G-rect is a more complicated class. It's got all kinds of little pieces of information because those little pieces of information exist in order to tell the computer what a G-rect is. So no, I can't store 4 different things inside of walls. However, G-rect is a complicated piece of information. It's not just it's not just a number or something. It's several numbers and then some other stuff. And so once I've got a G-rect in my walls, I can access any member of that particular G-rect and get that information separately. Like I could get its color or I can get its width or something like that. So understand that as the primitive versus reference thing. Reference variables are complicated because they have a lot of little primitive variables inside of it. Okay, moving on. You'll notice we've got our little red underlines here. That's because in order to create a G-rectangle, we have to tell it how wide and how tall it's supposed to be. So we give it a width and then a height. Let's start with 300 by 200. Remember, do not write the V, the colon, or the V1 and the colon. You only need 300, 200. Get used to the fact that the V's and stuff automatically appear.
No dimensions for a thick house?
We'll just start with 300, 200. We're going to change these later. So 300 by 200. Now once again, we have not just like with the G label when we were learning that, we haven't added this to the screen yet, so running our program still will appear to do nothing, even though all of the assignment and stuff happens in the background. If I want to add this to my screen, I have to say add walls. So write add walls like this, and then go ahead and run your program, and let's work from there. That's a problem, right? We want the walls to be centered. Heck, if we added a roof to this, we wouldn't even see it. So that's a problem. But it's an easy to fix problem. Because remember, just like with the G label,
Change its location.
we can change its location, or when we add it, we can tell it where to go. Now here's the thing though. I could just like guess that, okay, maybe halfway is about this, and I could just try it over and over and over again until I got really close, or actually got lucky and got it. But that's stupid, because I can actually just get the program to tell me exactly where the center is, if I know what I'm doing. The problem is that to do that requires coming up with a little bit of a formula, and writing that formula inside these parentheses for both the X position and the Y position is a little bit long and is easy to make mistakes. So we're going to organize this a little bit so that we don't have to worry about that. So if we go up here in between walls and add walls, what we're going to do is we're going to create two variables that we can store these formulas in, and then we'll just take those variables and put them in place of the formulas in the add method. If that doesn't make sense to you, you'll see in a minute. What I'd like you to do though is to declare two doubles, one named X and one named Y. They're local variables though, which means you do not put an access modifier. You just put the type and the name and a semicolon. That's it. Two doubles.
Declare.
Yeah, just declare them for now. Declare two doubles, one named X and one named Y. So that should have been pretty easy.
Can you change where 0, 0 is located?
No, not as far as I know. You can change the size of the window by like for its default, but you can't change where 0, 0 is. But that's okay because we can get around 0, 0 just fine. It's because it's set up as a grid system, and we're going to look at it here in just a second. Okay, hopefully we've pretty much got this. I'll wait just another second. Remember, just double X, double Y. So here's what this looks like.
Oh, my head.
I said declare some local variables, which means there's no public. In fact, I can't actually use the word public or private. The type is double. The name was X for the first one. And the second one is double Y. That's the declaration part. We haven't assigned them anything yet, but we're going to. Now let's get back up here on the board for a second. So let me help explain what we're about to do. So here's our window, which is that graph from before where I told you that 0, 0 is up here, and that this is positive Y, and that this is positive X. And that I told you, like, basically, like, that's the first rule of the ACM thing, is that positive Y is down for some reason. And so that's the first thing we have to remember. The second thing that we have to remember is that whenever we draw an object or a G object on the screen, it always starts drawing from the top left corner. So it always draws over and down. We need to keep that in mind as we make our formulas as well. Now, double X. That's going to be the X position of the walls. Not the width of the walls, but the X position. I want my walls to be center. If I wanted to center a picture on a wall, how would I find the center of the wall? Well, I'd measure the wall, but what would I be looking for?
If it's the same distance from the side.
Okay, so how do I find the middle of something? So I measured my wall, let's say it's 10 feet long. Divide it in half, right? 10-foot long wall, divide by 2, 5 feet. There's the center of the wall. Make sense? Everybody with that so far? Okay. So this is some width. We're looking for this. So I need to get half of that. And I can actually get the window to tell me. Remember that House Drawing is a graphics program because we extended it. So it has all the same methods and stuff that a graphics program has, even though we can't see them. One of those methods is called get width. Whoop. Like that. So we can set double X equal to the width of the window. So now in my computer's memory is however wide this is. We'll pretend it's 100. It's not at all. But that's basically what I just did. I had it measure itself and tell me how big it was. And then I stored that into a variable so I could use it later.
I'm getting an error on the equal sign.
Let's take a look. The semicolon you don't is the end of the statement.
It's saying that's
But get with this.
Unexpected item.
It'll convert it probably. There could even be different versions. There's actually built-in conversion stuff that just kind of happens automatically sometimes, especially when it comes to numbers. I just don't want to talk about it to confuse. So get width is going to return the width in pixels of the window. But if I want it centered, I got to divide that in half. Now, just for testing purposes, let's jump down here to our add call and pass it X, and we'll put 0 for the Y for now. We'll worry about the Y in a minute. So let's pass it X, and then draw it. Well, darn. Something happened.
You gotta change the y-axis.
Well, we'll worry about the Y in a minute, because the X is clearly wrong. So let's worry about X for now. So, really quick.
Couldn't you do 1/4? Because 1/2 is putting the X in the middle.
That's a good guess, but you'd be wrong, although we're going to test it anyway. So here's where we're at right now. So here's one potential solution. It's not right, but we're going to try it. Change this part right here, this get width divided by 2, to get width divided by 4. The logic on that one is, okay, well, if I go back a little bit, then that'll be okay. Now, that's not quite right, but run it and see. So that's not quite center, but we're closer. So what's wrong?
Is it the left line?
It is the left line. Switch this back to divided by 2. So first things first, when we're building these formulas, we need to be able to think of things in terms of just mathematical numbers. So I've got my Windows width of whatever. We're pretending it's 100 on the board, but I think it's actually closer to like 350 or something. This is drawing, we know where the center is, right here. But It's going too far over. So we could say that this is too far in the positive x. Does everyone agree with that?
So what you could do is to subtract half of the
That's right. So what we have to do is we have to pull the walls back. If we thought of this in physical terms, back on the hanging a picture thing, if I was trying to hang a picture on my wall, or I guess like this, and it's a little too far this way, all I do is push it this way. And the amount that I push it this way, in this case, is half of the width of the picture. Or in this case, or our walls, really. Does everyone follow that? Does that make sense to everyone? That's not a very affirmative.
Yes.
Okay. There you go. That's better. So we need to pull back. What would be the mathematical operator if I want to come back towards the left on the x-axis?
minus.
Minus, because positive x is this way, so negative x is this way. So I want to decrease my x value. So minus. So now how do I find out the width of the wall?
It's just
And let's pretend we have no idea. We know it's 300, but let's pretend we don't know that.
You do 1/2 the walls, or 1/2 the
Well, now we're getting closer. So yes, it does involve walls. But here's the thing. Walls is a G rectangle. It is not an integer. So I can't just say 1/2 of walls because the computer doesn't know what to do with that. Walls isn't a number it can just perform math on. Walls is a width, a height, an x position, a y position, a fill color, an outline color, and who knows what else. So it's this big collection of information like I mentioned earlier. So get width divided by 2, and then we have to do minus, and we can't just say walls divided by 2 because walls is too complicated. However, what is the aspect of walls that we need? What information do we need? We need to know how wide the walls are. So we can ask walls how wide it is. Walls.getWidth. And then, yeah, divide by 2. And if you run this, you will have centered walls. On the x-axis anyway. What I would like you to do now is to replace the 0 here with y, and then write the formula for the height under double y, and store that formula in there. I'll tell you when you get this right, it doesn't look quite right, and that's because of these 2 bars on the top,
Yeah, that's what I was going to say.
but it is right.
Do we know how? Wait, so does 0, 0 start like above the file line?
Yeah, it actually starts right here. So write that formula and store it into y. And then make sure that you replace the 0 with y there. I know it doesn't look centered, but it is. It's just because of these 2 bars on the top. Although, yeah, definitely looks wrong.
Divided by
I wish I was rich. I'd yell your father was wrong. This is a statement. Just do it. It only takes 2 seconds. Well, so we assigned x, so x is where we calculated where we want to throw that. Now you want to do it with Y. Because that won't work. You want height. And then so we should be starting to understand a little bit about how values and stuff get passed around. I think.
So when if you like change the size of the window, the square stays in the same spot.
Right. Can you think of why that might be?
No.
Well, it's actually a really simple thing. So are we giving any commands to like continually update this?
Oh.
We only add it to the screen one time. So to update it requires something we haven't learned about. Yes.
That makes sense.
You would have to basically set an infinite loop that runs this code over and over and over again, ad nauseum, which could actually crash your program eventually.
Okay.
But not necessarily. It just creates a thread, and you need to make sure that thread dies at some point. But there we have it. So what is the formula for the Y value?
Get height by 2.
That's it. And just like that, our draw walls method can draw our walls perfectly centered on the window like we said we wanted.
We said to get width for the Y one. Oh, I did width for the same thing.
What's that?
I feel like get width from the Y. It's the same thing.
Well, so the window is square by default, so get width divided by 2 might work, but the walls are not square. You change the walls.
So,
The walls aren't square, so get width is doing 300 divided by 2, but you want 200 divided by 2.
so it's just cross the wrong line.
Yeah, it just has to, it's because of the bars on top of the screen that looks so weird, but that is correct.
Oh, what does that mean?
It, you'd think, but it's just an optical illusion. It is actually.
Well, if you're putting in a like the bars, it's still no, that's right.
Just to be clear about this, the last thing I want to go over today, just to be clear about how this works, all of these this should help you understand return methods better. If I can find the little minus symbol. There it is. Okay. This should help you understand return methods better because get width and get height return numbers. So this is literally a mathematical calculation that says whatever the width is minus whatever the width of the walls is, which we know is 300. Divide both of them by 2. I can actually get it to print this out. I can say system.out.println. I could pass x, and it'll print out whatever x happens to be. I can print y, and it'll tell me y. And here I can say, tell me how wide my window was to begin with.
Are we copying this part down?
You don't have to. This is just me showing you that all this really is masking numbers. So if I run this, I'm going to get this printout that shows me what all of these values are. So X is evaluating to 227. Y is evaluating to 146. Get width is 754. So the window is drawing at 754 pixels wide. And the height of the window is 492 pixels tall. And so next class, I know we're finishing a bit early here, but that'll just give you some chill time. Next class, we're going to be doing all the other components of the house. I don't know if that's Tuesday or Wednesday. Please, for the love of God, do not forget all of this stuff over the long weekend.
I think we got
What class are we in again?
But this will do for today. All of this. Everything.
Control S is saying.
So save your work. And then for anyone who is watching this extraordinarily long video, goodbye.